According to Dalton's early atomic theory, atoms are considered to be indivisible by any mechanism. Now, as soon as you kind of say that to a scientist, they're going to want to try and prove you wrong. That's what scientists love to do to one another. They always want to improve previous theories and come up with better ones. So for a good solid, 90 years after Dalton's atomic theory was proposed, people were working really hard to see if they could find particles within atoms, to see whether they could find what we call subatomic parts of atoms. So the first real result, solid result in this area was the result of work done by a British physicist called J.J. Thomson. This came about 90 years after Dalton. And what J.J. Thomson discovered was that there was these rays that were emitted, and I'll explain how, from a metal plate that had an electrical charge, and these rays seem to be composed of what we call subatomic particles. So I'll show you the setup that he had. He had a big, long glass tube, and on the inside of this glass tube at one end, he coated it with a material called phosphor that glows if any electrically charged particle hits it. At the other end of the tube, he had a metal plate. And this metal plate was connected to a power supply, to a battery, and it was connected so that it had a negative electrical charge. Okay, just in front of this first metal plate was another metal plate, but he very wisely put a little hole in the middle of that plate. Well, it was more of a slit than a hole. And this metal plate, he hooked up to the positive terminal of a battery. So what we know is we have one plate with a negative electric charge and another plate with a positive electric charge just in front of it. And what happens when you hook this up to the battery? Well, it was found that you got a little glowy green dot on your screen, which indicated that an electrically charged particle was heading down the tube. As soon as you disconnected the battery, the glowy green dot went away. As soon as you connected the battery, it came back. So what did Thomson recognize? Well, he said it was moving away from the first plate. And as the first plate had a negative charge, then the thing that was being repelled down here also had a negative charge. And that made sense because it was being attracted towards the plate that had a positive charge. And some of these particles are getting through because you get the glowy green dot at the end. Okay, so then he did a whole bunch of really cool experiments. He knew that electrically charged particles were influenced by magnets. So he put a couple of magnets either side of his tube, and he moved those magnets in and out, in and out, in and out, and he saw how strongly this little green dot was moved up and down. He also knows that these negative particles are going to be attracted towards a positive charge and repelled by a negative charge. So he put metal plates, and again, he could move this little green dot up and down as he wanted to. So what he did was a whole bunch of math, and he could see how hard it was to make this green dot move, to make these particles move. And he was able to calculate what's called the mass to charge ratio of this, whatever this negatively charged particle was. And what he found was it was really, really small. It was smaller than anything that had been observed for any atom. And so he concluded that these negative particles must be a subatomic particle. They must be part of an atom. So he said that these rays were subatomic particles. We now call these subatomic particles electrons, and we give them the symbol lowercase e superscript minus. So what's really cool about this is that the observation of subatomic particles means that Dalton's first rule, which says that atoms are indivisible, or at least in part it says that atoms are indivisible, has to be incorrect. It can't be the whole story, and so this is the gateway towards a new, more modern atomic theory. So the problem is that we just have the mass divided by the charge at the end of Thomson's work. What we really want is the mass. So to get the mass, you need to take Thomson's ratio and you need to multiply it by the charge of the electron, and then you're going to get the mass, and that should hopefully be smaller than the mass of any atom. So an American physicist by the name of Richard Milliken, he was able to determine what the charge was on the electron, and he did it in a really kind of interesting way, and it's quite complicated, but it actually turns out that you can do it yourself. And I'm not going to go through all of the math, but how he did it was he would create little electrically charged drops of oil and he would levitate them. And by determining like how much energy was required to levitate these little oil drops, he was able to figure out the charge on the electron, and then he combined that with Thomson's data. So he figures out that the charge on the electron is minus 1.6 by 10 to the minus 19 coulombs. And so he combines this with Thomson's data, as I said, and he gets the mass of the electron. And sure enough, the mass of the electron is less than 1/1000th the mass of the smallest, lightest atom, which is the hydrogen atom. So the first subatomic particle has now been completely characterized. We know its mass, we know the sign of the charge, and we know the value of the electrical charge. So of course at this point the question becomes, are there any more subatomic particles? Now we know that atoms are electrically neutral. So if atoms have negative electrons, there has to be something that balances out the charge to give an overall electrically neutral atom. So there has to be some stuff that is positively charged in the atom. And of course, a big problem is that the electron is just a tiny, tiny little fraction of the mass of the atom. So that means there has to be something else present that makes up the rest of the mass. So Thomson proposed that atoms looked a little like this. He called it the plum pudding model of the atom. So you have this big, dense, heavy ball of matter, and that has a positive charge. And then embedded in that positive charge are the tiny, light, negative electrons. Okay, and that's it. So the interesting thing about this model is, the density of the atom is approximately the same all the way through. It's not like there's no hollows in it, right? It's got the same kind of doughy consistency all the way through. It's like a cake. That's why he called it the plum pudding model. He was thinking it's like a fruit cake, right? All right, so that's where we're at this point. So is it correct? Okay, or are there, is there something else going on? So how can we test this? How can we find this out? So it turns out that people went on and they discovered other subatomic particles. In fact, we found that there are 3 subatomic particles that we need to characterize all of the atoms on the periodic table. And these 3 subatomic particles are called neutrons, protons, and electrons. And their properties are described below. So the electron has a charge of -1, and it has very little mass, and we give it the symbol E superscript minus. The proton has an opposite charge to the electron. It has a charge of +1, and it has a mass of about 1 atomic mass unit. And we normally give the symbol for the proton as a lowercase p with a superscript plus. And then our third subatomic particle is called the neutron. And the neutron is electrically neutral, and it's a tiny little bit heavier than the proton, but it has a mass of 1 AMU, or very close to 1 AMU. And the symbol for the neutron is normally a lowercase n. Sometimes people do N0. So an atomic mass unit, which is the unit of mass that we use to measure tiny little things like atoms and subatomic particles, to give you kind of a feel for how big that is, it is 1.67 by 10 to the minus 24 grams. And 1,000 grams is about the mass of a quart of water. So if that helps you understand how small these particles are. So something to recognize is that protons and neutrons are very heavy compared to the electrons. That's where most of the mass of atoms are. And then the other thing to recognize is that because electrons and protons have opposite electrical charge, they are going to be attracted to one another. But electrons will be repelled from one another, and so will protons. Okay, so we've defined all of the subatomic parts of the atom. There are 3 subatomic particles: protons, neutrons, and electrons. Protons have a charge of +1. Neutrons have a charge of have no electrical charge. Electrons have a charge of -1. Protons have a mass of about 1 AMU. Neutrons have a mass of about 1 AMU. And electrons have a mass of about 0 AMU. Not very heavy at all. Because protons and electrons have an opposite electrical charge, these guys are going to attract one another.